Hello everybody and welcome back to Absolute Value. Today we are going to start a little series that I'm going to do of reviewing for the Algebra 1 Regents. So Algebra 1 Regents is June 17th this year. So we're going to get started with doing some review. And starting with quadratics. Quadratics is usually the last thing you learn in Algebra 1, and so I just wanted to start here because sometimes, as a teacher, maybe you run out of time at the end of the year and you don't fully get that whole quadratics unit in there. So I'm actually going to start with quadratics, which are typically the last unit that you cover in Algebra 1. So I'm going to start with solving quadratics, which is typically the last unit that you cover in Algebra 1, because sometimes maybe you don't get too much time in quadratics and you don't get to spend as much time practicing how to use these different methods of solving quadratic equations. I've got some past Regents questions here that we're going to go through that are all about solving quadratics, and I'm going to show you all different methods as well as some pitfalls to avoid, things to not do on your Regents. Alright, starting with question 49 here. What is the solution set to the equation 3x squared equals 24x? The first thing people want to do when they see this is, oh, there's an x on each side, so let's divide both sides by x. And then that cancels out the x here and cancels out one of the x's there, and that helps you solve for x. But no, that is not allowed. That is not allowed. You cannot divide by x, because that will get rid of one of your solutions. But instead, this is what you should be doing. So instead, we should try to put it into standard form, which means getting the x to the same side as the x squared and everything equaling to 0. So to do that, we subtract 24x from both sides. And remember, what you do to one side, you must do to the other. That is the golden rule of algebra. These go away, and we're just left with. From here, we can do a method of factoring called greatest common factor, where we take out the biggest possible number that can go into each of these terms, and the biggest possible variable as well. Okay, so biggest possible number is going to be 3, and the biggest possible variable is x. So then we just need to think about, well, if we divided this by 3x, what are we left with? X. If we divided this by 3x, what are we left with? Minus 8. Now we just do a little zero product property. Divide those up. We have 3x equal to 0 and x minus 8 equal to 0. Solve for x. Over here, x is just 0, and over here, x is positive 8. So then our solution set is 0 and positive 8, which is answer choice 2. Going on to the next problem, number 50, it says which equation is equivalent to x squared minus 6x equals 27? And so from looking at the answer choices, we can tell that they are doing a little bit of completing the square. So we need to figure out what we need to add to both sides. That will give us a hint for what this right side is going to be, since the left side, they're all the same. So when we're doing completing the square, we need to add something to both sides. I like to write a plus and then a blank on each side, just to remember that on both sides you're going to be adding the same thing. And then we already know that this down here is going to be x minus 3 squared, because remember this number in the parentheses is half of the b term. And then the number that you add to both sides is going to be this number in parentheses squared. So negative 3 squared is 9. So now we have on the right side 27 plus 9, which that's answer choice 2. Going on to number 51 here. Which equation has the same solution as x squared minus 6x equals 24? This is the same kind of thing. In fact, similar numbers as well. So same setup. This time all of the left sides are not all the same, so we're going to have to figure out which one that is. But remember, this number in parentheses is half of the b. So half of negative 6 is negative 3. And then to get what's in the blank, that's going to be negative 3 squared, which is 9. And on the right side, 24 plus 9 gives us 33, which that is answer choice 3. Be careful here, they're trying to trick you with the first one, because the first one has the same left side, but they forgot to add the 9 on the right. So be careful and make sure if you add something to one side, you add it to the other as well. Now let's look at another one. Number 52, which equation has the same solution as x squared plus 6x minus 18 equals 0? Looking at the answer choices, this again is a completing the square. So first thing we do with completing the square, first thing I like to do, is to move the constant term to the other side. So this 18, let's add 18 to both sides so that there's no more negative 18. And then we know we're going to be adding something to both sides. So I put my little plus and underline. The number that goes in the parentheses is half of b. So half of 6 is 3. That means this number up here is 3 squared, which is 9. So 9 over here as well. Simplify the right side. 18 plus 9 is 27. So that goes with answer choice 2. So 53 is another problem we could do, but it's very similar to the ones we have just been doing. So I'm going to actually skip to 54, which has a solve completely for x. For number 54, we have x squared plus 8x equals 33. And we need to solve this by completing the square. So I'm just going to rewrite that using my little blanks. And then we know this bottom part is going to be x plus 4, because 4 is half of 8. This up here is 4 squared, which is 16. So this is 16 as well. 33 plus 16, 49. From here, we need to go a step further and actually find what x is. In order to do that, we need to know, inside this parentheses, what number do we square to get 49? And that number is 7 or negative 7, right? Both of those numbers multiply by themselves to get a positive 49. So that means this thing in parentheses, this x plus 4, has to either be 7 or negative 7. And from there, we can solve for x. And there are 2 x values. I'll do one more of these completing the square ones. I'm going to do number 55 because you'll see that this one we get slightly different kind of answers. Since it tells us express your answer in simplest radical form, that's already telling me that we're probably going to see some radicals in our answer. So again, the first thing we're going to do here is move the 41 to the other side by adding 41 to both sides. And I'm just going to add in my plus and the spaces there because I know we're doing it by completing the square. Now, same thing as before. The number in the parentheses is half of b. Half of 6 is 3. That means the number up here is 3 squared, which is 9. This is 9. The right side is 41 plus 9, which is 50. So here's where we get to a spot that's different from the last one. Because in the last one, we could find a nice number to multiply by itself to get 49. Here, we don't have such a nice number. In reality, if you think about it, how we get this 7 from the 49 is we take a square root of both sides. We do that in order to cancel out with the squared and the squared cancel each other out, and then the square root of 49 is 7 and negative 7. When we take a square root in this case, we have to do a positive and a negative. So I'm going to do basically the same thing here. So square root both sides, but remember we also need a positive and a negative square root. So then just to rewrite that a little bit, that cancels out the square root and the squared go away, and we're just left with x plus 3 equal to plus or minus the square root of 50. And then the last thing to get x by itself is just to subtract that 3 from both sides, so we'd get x equals negative 3 plus or minus the square root of 50. And they want it in simplest radical form, so let's remember how to simplify square root of 50. We have to think what perfect square is inside of 50. 25. So this 50 is 25 times 2. So square root of 50 is square root of 25 times square root of 2. Square root of 25, though, is 5. So this is our simplified radical. Now let's just put that back in for the square root of 50, and that will give us our final answer. So there's our final answer. Don't forget to include the plus and the minus because there are 2 answers in this problem. There are 2 answers. One is negative 3 plus 5 square root of 2. The other is negative 3 minus 5 square root of 2. So that's how we would do completing the square when we don't get such a nice number. Typically, you'll see them ask you to express your answer in simplest radical form. That kind of gives you a clue that you're not going to get a nice answer. Otherwise, you typically should get a good answer. So now we're going to do a few more with a different method of solving. All right, so now we're going to do a few more problems. And these ones are going to involve a different method of solving quadratics, which is called the quadratic formula. And if it helps, okay, so now we're going to do a few more problems, but we're going to use a different method of solving them called the quadratic formula. This right here is the quadratic formula, and if you have a hard time remembering it, it is typically on the reference table. But there is also a song that goes x equals negative b plus or minus square root b squared minus 4ac all over 2a. And if you start singing that song during the Regents, I don't think they would like it, but sing it in your head, and it'll help you out. So let's walk through how to do this using number 57 here. This has to use the quadratic formula to determine the exact roots of this equation, x squared plus 3x minus 6. So notice in our quadratic we have a couple different letters here. We have a, b, and c. Those refer to the numbers that are in our equation. The a term is the number in front of the x squared. The b is in front of the x. And the c is your constant, assuming everything is equal to 0. It must be equal to 0 first. So from here, we know that a is 1, b is 3, and c is negative 6. So we can take those numbers and plug them into your equation. I would recommend writing out what a, b, and c are like this every single time, just so you don't get confused as you're plugging things in. So let's just get right into it and plug in those numbers. So there it is, all substituted in. Now we can just do a little bit of simplifying. So this is your answer. These are the exact values for x. Two values here, right? Because we have a plus and a minus as our two different answers. And that is your solution, as gross as it is. That's the answer. Let's do one more practice problem here with the quadratic formula. This one is number 58. Solve x squared plus 4x minus 3 equals 0. So again, our a here is 1, b is 4, and c is negative 3. So let's just plug everything in. So this is as far as we simplified it in the previous one, but in this case, we actually can do something with this square root of 28. Like we did previously, we can simplify this radical. Square root of 28, what perfect square goes into 28? It's 4. That means this is the same thing as 2 square root of 7. So then we'd really have this, which if we take a 2 out of each piece, divide this by 2, then this is negative 2, divide this by 2, divide this by 2, then we'll just get x equal to negative 2 plus or minus square root of 7. So that's our answer. All right, so there are a few more problems on this sheet here and on this page that you can see that I did not solve. If anyone has questions on the ones I did or the ones that I didn't do, feel free to put a comment and I will make a video or respond in the comments as best as I can and help you guys out. So that's all we're going to do for this video. Feel free to come back next time. Make sure you subscribe in order to know when I post new videos. And I'm going to post some more algebra review in the future. I'm also going to be doing geometry and algebra 2 review for the Regents and pre-calculus final exam review. So stay tuned for any of that, or tell your friends or siblings if they are taking those things and need help with them to check out my channel. And as always, thank you so much for watching. Leave this a like or a comment if you have any questions or comments, and I'll see you next time. Thanks for watching and happy studying.